Hello everyone, for today's video, we will discuss basic integration, integration by substitution, integration by parts, and definite integrals. For our today's lectures, we have me, Raycel Maratas, and George Biñas. So let us now proceed with our lessons. In this video, we will go over some basic integration rules. So let's say you want to integrate 5 dx. So in the formula, we can see that the integral of k dx is equals to kx plus c. The k in this problem is 5, which is the constant. So let's follow the formula. So it will be 5x plus c. So this will be the final answer. Another example is the integral of 1050 dx. So again, the k in this problem is 1050, then x, because of kx, plus c. This is the answer. Another rule you need to know is the power rule. The formula in this rule is the integral of x raised to n dx is equals to x raised to n plus 1 over n plus 1 plus c. So let us try. For example, we have the integral of 10x raised to 4 dx. So here, since we have a constant 10, we just need to copy 10. Then, as we can see, x raised to 4 is x raised to n. So we just need to follow the formula. So it will go x raised to 4 plus 1 over n, which is 4 plus 1 plus c. So simply simplify. It will be 10x raised to 5 over 5. So as you can see, we can cancel 10 and 5. It will give us 2x raised to 5 plus c. So this will be our final answer. So let's say you were given the problem, the integral of 1 over x squared dx. So as you can see, we have x squared on the denominator, and as we know, we can put the x squared in the numerator by putting a negative exponent. So it will be x raised to negative 2. So this will be our new problem. So we can proceed from here. Let us apply the formula in the power rule. It will be x minus 2 plus 1 over negative 2 plus 1 plus c. So all we have to do is to simplify. So this will give us x raised to negative 1 over negative 1 plus c. So again, simplify. It will give us, since x is raised to a negative exponent, we will bring down x. So this will give us negative 1 over x plus c. This will be the final answer. So in the third rule, which is the fraction rule, we will see ln. So the formula in this rule is integral of 1 over x dx is equal to ln x plus c. So this rule only applies to certain problems such as this. So let's say we were given the problem, the integral of 1 over x plus 5 dx. So we just need to follow the formula. So ln x here is x plus 5. So it will be ln x plus 5. Then we have to get the derivative of x, which is x plus 5. So derivative of x plus 5 is simply 1, then plus c. Simplify the problem, so this will give us ln x plus 5 plus c. So this will be our final answer. So another problem is let's say we were given the integral of 1 over 4x minus 3 dx. So the same as before. So let's find ln x first. So ln and x is 4x minus 3, 4x minus 3. Then get the derivative of 4x minus 3, which is 4. Plus c. So that's it. This will be the final answer. For the next rule, which is the exponential rule, we have the formula. The integral of e raised to kx dx is equals to 1 over k times e raised to k plus c. So let us try. So the integral of e raised to 4x dx is equals to, so let's follow the formula. 1 over k, so k in the problem is 4. So 1 over 4 times e raised to k, which is, we just need to simply copy. So e raised to 4x plus c. So we just have to multiply or simplify this. So it will be e raised to 4x over 4 plus c. This will be our final answer. So let's have another problem. So let's say you're given the problem, the integral of e raised to 7x minus 3 dx. So again, we just need to follow the formula. So 1 over k, k here is 7. So 1 over 7 times, copy, e raised to 7x minus 3 plus c. So we just have to simplify or multiply 1 over 7 to e raised to 7x minus 3. So this will give us e raised to 7x minus 3 over 7 plus c. So this is our final answer. So for our final rule, which is the addition and subtraction rule, we have this formula. The integral of f of x plus or minus g of x dx is equals to the integral of f of x plus or minus g of x dx. So in here, we simply have to apply the previous rules to the problem. So let's say we have the integral of 3x plus 4x squared minus 1 over x cubed dx. So in this problem, we can use the power rule. So let's apply the power rule. So it will be 3x. So since x is raised to 1, so plus 1, it will be 2. It's raised to 2 over 2. So then 4x. So 2 plus 1 is 3. So 3 minus, so again, the x raised to 3 is in the denominator. So we can pull it up. So it will be a negative exponent. So x. So negative 3 plus 1 is negative 2. So negative 2 over negative 2. So simply simplify. So this will give us 3x squared over 2 plus 4x cubed over 3, then plus, since negative times negative 2 is positive 2, so this will be plus. So we will now bring down x since it has a negative exponent, so this will give us 1 over 2x squared plus c. So this is the final answer. So let's have another given. So say we have a problem, the integral of 3e raised to 4x plus minus 4 over x squared plus 3 dx. So again, in here we can see that we can apply the power rule in 4x minus 4 over x squared. Then we can apply the constant rule in 3 and the exponential rule in 3e raised to 4x. So let us try. So this will give us 3e raised to 4x over 4 minus 4x. Since x is in the denominator, we will have the negative exponent in the x, so it will give us negative 2. So negative 2 plus 1 is negative 1 over negative 1 plus, so 3, all we have to do is add x, so 3x. So simplify, so this will give us 3 raised to 4x over 4, so negative and negative, so plus 4, so we have a negative exponent, so we'll bring down x, 4 over x plus 3x plus c. So this is our final answer. So for trigonometric functions, we have the integral of sine x dx is negative cosine x plus c. Cosine x dx is equals to sine x plus c. Secant squared x dx is tangent x plus c. Secant x tangent x dx is secant x plus c. Cosecant squared x dx is negative cotangent x plus c. And cosecant x cotangent x dx is negative cosecant x plus c. As we can see, this is simply the opposite, or we just have to switch the positions in the original formulas of the derivatives of trigonometric functions. So let us try. So for our first example, we have the integral of 3 sine x plus 6 cosine x dx. So in this problem, we simply have to copy the constant and get the integral of the trigonometric function. So 3, so the integral of sine x is negative cosine x. So we have negative 3 cosine x. So cosine x is sine x. So we have plus 6 sine x. So this, and don't forget plus c. So this is our answer. So let's have another problem. So for our second problem, we have the integral of secant x times cosine x plus tangent x dx. So before we get the integral of this problem, we can see that we can distribute secant x to cosine x plus tangent x. So let's do that. So that we will have the integral of secant x cosine x plus secant x tangent x dx. So as we can observe with our new problem, we already have secant x tangent x. So we can just say that it's secant x. So for secant x cosine x, we know that the equivalent of secant x is 1 over cosine x. So let's do that. So it will be integral of 1 over cosine x times cosine x plus secant x tangent x dx. So let us cancel cosine x. So we will have the integral of 1, since all we have is 1, plus secant x tangent x dx. So what's the integral of 1 plus secant x tangent x dx is x plus secant x plus c. So this is our final answer. In this lesson, I'm going to show you how to integrate using the U substitution. So let's say we have the problem, the integral of 4x times x squared plus 5 raised to 3 dx. So in order to find the integral of this problem, we have to identify the u variable and du. So whatever we select as u, we have to get its derivative. So if we use 4x as the u variable, its derivative is 4. So since the derivative is 4, we cannot cancel x squared plus 5 or the x in x squared plus 5. So we cannot use 4x as u. So instead, we will use x squared plus 5. So the u will be x squared plus 5, and its derivative is 2x. So we will put dx. So our next step is to equate dx to du. So we have to do is to divide 2x on both sides. So cancel. So du over 2x is equals to dx. So what we have to do now is to replace this one with du and this one with du over 2x. So let's do that. So the integral of 4x is 4x times u raised to 3 and du over 2x. So as we can see, we have 4x and 2x, so we can cancel them. So we can cancel x. So we're gonna have 2 times the integral of u raised to 3 du. So what we need to do next is to simply apply the power rule on u raised to 3. So we have 2 raised to 3. So u 8. So 2 times u raised to 4 over 4. So yeah, this will be the answer. This will be the answer, but it's not yet done. So we have to, as we can see, we can cancel 2 and 4. So cancel. So this will give us 1 over 2 u raised to 4. So all we have to do now is to replace u with x squared plus 5. This one. So we're gonna have 1 over 2 x squared plus 5 raised to 4. So this is not yet our final answer, so we can multiply 1 over 2 to x squared plus 5 raised to 4. So this will give us x squared plus 5 raised to 4 over 2 plus c. So this is our final answer.
Now we will be solving for integration by parts. And the formula for this is the integral of u du or u dv minus the integral of v du. And in this, we have an acronym to abide for determining our values, which is LI ATE. And L stands for logarithmic function, I stands for inverse function, A stands for algebraic functions, T stands for trigonometric functions, and E stands for exponential functions. Suppose we have an equation of the integral of ex dx. We would have to determine what is the u, du, dv, and v. So here is where we will use the acronym in determining it. So since a comes first, which is the algebraic expression of x, so u equals x, and what's left is ex dx is the exponential function which we will place in dv, which dv is equal to ex dx. So u equals to x, and du is the derivative of u, which will be 1 dx. dv is equal to ex dx, and v is the derivative of dv, which is ex. Now we substitute to the formula. U is equal to x times v is equal to ex minus the integral of v is equal to ex times du, which is 1 dx. Now we integrate ex minus the integral of ex times 1 dx is equal to ex. So since we are done, we will just have to add our arbitrary constant, which is c. So our final answer is the integral of ex dx is equal to ex minus ex plus c. Let's solve for another example. The integral of x cosine x dx. Now we will need to use the acronym in determining the order. Since the algebraic expression comes before the trigonometric function, we will use the algebraic expression x to represent u. So u plus x, u is equal to x, and what's left is cosine x dx. So dv, which is the trigonometric function, we will place cosine x dx in dv. So u plus x, u is equal to x, and du is the derivative of u, which is x, and the derivative of u is 1 dx. dv is equal to cosine x dx, and the derivative of dv is v, which is sine x. Now we substitute uv, or u is equal to x, and v is equal to sine x, minus the integral of v, which is sine x, times du, which is 1 dx. Now we integrate. X sine x minus the integral of sine x dx, which is cosine x. Since we are done, we will add our arbitrary constant c. So our final answer is the integral of x cosine x dx is equal to x sine x plus cosine x plus c. Let's solve for another equation. The integral of ln x dx. Here we'll again use our acronym in determining the order. Since logarithmic function comes before algebraic function, we will use ln x for u to represent u. U is equal to ln x, and what's left is dx, which is the algebraic function dx. We will place it in dv. So u equals to ln x, and du, the derivative of u, is dx over x. And dv equals to dx, and the derivative of dx equals to v is equal to x. Now we substitute. u is equal to ln x, and v is equal to x, times or minus the integral of v is equal to x times du, which is dx over x. Now we integrate. X ln x minus the derivative or the integral of dx, which is x. So since we are done, we will add our arbitrary constant, which is c. So our final answer is the integral of ln x dx equals to x ln x minus x plus c. Get our antiderivative. To get the antiderivative of 2x, you need to use its formula of x raised to n plus 1 over n plus 1. And the antiderivative of 2x is x raised to 2 plus 1 over 2 plus 1 equal to 3x cubed over 3. And we substitute our limits, which are 3 and 6. 3 substituted to x, which will be 3 raised to 3 over 3, minus 6 substituted to x, which will be 6 raised to 3 over 3. Then we simplify. 3 raised to 3 over 3 is equal to 27 over 3 minus 6 raised to 3 over 3, which will be 216 over 3. Since we can still simplify, 27 divided by 3 will be 9, minus 216 divided by 3 will be 72. 9 minus 72 is equal to our final answer, which is negative 63. Let's solve for another equation, a constant. 6dx evaluated from 8 to 3. How exactly do we get the antiderivative of a constant? To get the antiderivative of 6dx, you just need to multiply it by x. So the antiderivative of 6dx is 6x. Since the derivative of 6x is 6, its antiderivative is 6x. Then we can now substitute our limits, which are 8 and 3. 8 substituted to x is 6 times 8, minus 3 substituted to x is 6 times 3. Then we can now simplify. 6 times 8 is 48, minus 6 times 3 is 18. 48 minus 18 is equal to our final answer, which is 30. Let's solve for another equation. A polynomial function, which is 4x cubed minus 8x plus 4 dx, evaluated from 3 to 4. To get our antiderivative of this polynomial function, we need to use its formula of x raised to n plus 1 over n plus 1. So the antiderivative of this polynomial function is 4x raised to 4 over 4 minus 8x raised to 2 over 2 minus 4x. Then we can now substitute our limits, which are 3 and 4. 3 substituted to x is equal to 4 times 3 raised to 4 over 4 minus 8 times 3 raised to 2 over 2 plus 4 times 3 minus 4 substituted to x will be 4 times 4 raised to 4 over 4 minus 8 times 4 raised to 2 over 2 plus 4 times 4. Now we can simplify, but first, according to Penda's rule, we need to solve what is inside the parentheses first. So 4 times 3 raised to 4 over 4 will be 4 times 81 over 4 minus 8 times 3 raised to 2 over 2 will be 4 times 9 over 8 times 9 over 2 plus 4 times 3, which is 12, minus 4 times 4 raised to 4 over 4 will be 4 times 256 over 4 minus 8 times 4 over 2. 8 times 4 raised to 2 over 2 will be 8 times 16 over 2 plus 4 times 4 will be 16. Then we can simplify further. We can cancel 4, which will be left of 81, and we can cancel 2 to 8 will be 4 times 9 plus 12 minus, we can cancel 4, which will be left with 256 minus, we'll cancel 8 and 2, which will be left with 4, and 4 times 16 plus 16. Then we can simplify further, which is 81 minus 4 times 9 will be 36 plus 12 minus 256 minus 64, which is 4 times 16, 64 plus 16, and to sum it all up, we will have 81 plus 36, 81 minus 36 plus 12 minus 256 minus 64 plus 16. It is all equal to our final answer, negative 247.